Okay, so let's dive into this idea that web pages aren't just static, right? They actually react to what you do.
Exactly. Your clicks, typing, even just resizing the window.
Hmm.
It all triggers something.
And that something is what we're calling browser events, these little signals flying around.
Precisely. They're like notifications saying, hey, something just happened over here. Understanding them is pretty key.
Absolutely. It's fundamental if you want to build anything interactive, anything that feels, alive. That's our goal today. Sort of unpack how we listen for these events and make things happen.
Yeah, and the core way we do that, the standard approach, is using Add Event Listener.
Right. So you basically pick an element on the page, could be a button, an input field,
Or
whatever,
even the whole document, yeah.
and you tell it, hey, listen for this type of event, like a click.
Element.addEventListener. Click my function. That's the pattern. And my function is the code that runs when the click actually happens.
Okay, simple enough. But what's really useful, I think, is that my function gets automatically handed some information, doesn't it?
It does. It receives an event object. Think of it as a little data packet about the event.
And that packet has some crucial details inside, like what specifically got clicked.
Exactly. That's the event.target property. It tells you the innermost element that the event originated from. So if you click a specific word inside a paragraph, the target is that word element, maybe a span.
Ah, okay. And that's different from current target.
Right. Current target is the element your listener is actually attached to. So if your listener is on the whole paragraph, current target would be the paragraph, even if the target was that specific span inside it.
Gotcha. Knowing the difference there seems pretty important for debugging or more complex scenarios.
Definitely. And it leads straight into understanding how these events actually travel through the page structure, through the DOM tree.
You mean bubbling and capturing?
Yep. By default, most events bubble. So that click on the span, the event fires there first.
On the target.
On the target, yes. Then it travels up to the parent paragraph, then its parent div, all the way up to the document. Any listeners for click on those ancestors will also fire in order.
So it bubbles up like, well, a bubble.
Kind of, yeah. Capturing is the reverse trip down from the document to the target. It happens first, technically, but we usually attach listeners during the bubbling phase. It's just more common.
But knowing capturing exists gives you options, maybe, for intercepting things early.
Exactly. More control if you need it.
And we can actually control this flow, right? With the event object, like stop it from bubbling further.
Yes, event.stopPropagation. That's the one. If you call that inside your listener, the event stops its journey right there. It won't travel any further up the chain.
Okay. Useful if you have nested clickable things and don't want them all to react.
Precisely. And then there's event.preventDefault. That's another big one.
Stopping the browser's default behavior, like stopping a link from actually going to a new page.
Exactly that. Or stopping a form from submitting in the traditional way so you can handle it with JavaScript instead, maybe send the data asynchronously. Super common in modern web apps.
Okay, this all makes sense for individual elements, but what if you have like a lot of similar elements, a long list of items maybe, and you want each one to be clickable?
Yeah, putting a listener on every single list item, that can get inefficient pretty quickly. Memory usage goes up, performance can dip.
So there must be a better way.
There is. Event delegation. It leverages that bubbling concept we talked about.
How does that work?
Instead of adding listeners to every child element, you add one single listener to their common parent container, like the USL element for a list.
Okay, one listener on the parent.
Right. Then, when you click on any list item, lie, the click event bubbles up from the lie event.target to the USL where your listener is waiting, event.currentTarget.
Ah, I see. And inside that single listener function on the us, you check event.target to figure out which lie was actually clicked.
Exactly. You use event.target to identify the specific child that triggered the event and then run the appropriate code for that item. It's way more efficient.
And it works even if you add new lift items later with JavaScript, right? Because the listener's on the parent, it doesn't care.
Correct. It handles dynamically added elements automatically. It's a really robust pattern.
Okay, so let's recap quickly. We started with events as signals. We use addEventListener to listen.
We get that handy event object with details like target and current target.
We understand the flow, bubbling up, capturing down, and how to control it with stop propagation and prevent default.
And finally, we use event delegation for efficiency, especially with lots of elements, by listening on a parent.
Getting a solid grasp on all this really feels like a major step up for anyone wanting to build more dynamic, responsive web apps. It moves you beyond just static pages.
Absolutely. It's foundational for creating those rich user experiences we expect now.
So, To leave everyone with something to chew on. Thinking about how central events are, not just in browsers, but in computing generally, user input, system notifications. How might really mastering these event handling patterns change the way you approach designing or even just debugging user interfaces in the future?
That's a great question. Does it make you think differently about structure, about efficiency, about how the user actually interacts with the system? Lots to consider there.